And a very good day to everybody. So for this video, we are going to concentrate on how we are going to generate the machine code for some of the instructions. And basically for today's lecture is we are going to learn how to use the reference manual, how you want to change or get the machine codes for few of the instruction that we're going to learn. Alright, what you need to have is the first one is the programmer's manuals, which is the one that I already give you guys through the ULearn from the WhatsApp group. So this is documents that you need to understand. You need to read and understand how to use it. So the skills here is once you know how to use it, so it should be okay, or it should be easier for you to change or get the instruction code for the other what you call that, the syntax that you guys use in the program. so what you are going to look at is actually the instruction code. So before that, we are going to get back to the theory. All right, so again, when you are doing your programming, right, when you write the code, right, that's for example, when you write your code okay, so when you write the code here in your assembly language, right, so for example, in the assembly language, you are going to use move anyway, move.w, right? So you have maybe this one to D7, for example. So this is the one that you understand. Whereas that when you need to you need the machine, or the what you call that, the compiler, the system to understand what you're using. So you need to compile this process, this syntax, compile it, and later you got some a code. For example, maybe for example just be ABCD. For example, this is just example. Alright, so this will be the code. So the process here for today that we're going to learn how to convert this one, you as your compiler, and get this number. Alright, so based on the previous slides, right, for example, if you look at the previous slides, there are some of the code or syntax you already have the machine code put over there. For example, here in this case, right, you have the machine code for this syntax is D2C4, $sign is in hexa numbers, and for this add.long, add address, you have this one, and so on. Alright, so this will be the machine code for it. So in Easy68K, for example, let's look at your Easy68K. Right, Easy68K is here. For example, that you just go to your code here, just type very simple code. The one that we learned, very simple, is to move. Alright, so move.byte, alright, D5 to D7. Okay, so this is the one that you understand. So when you compile it, right, you will open up this one, and the machine code is over here. The machine code here is $1E05, and this instruction code is located at the memory address at 1000, because you start your program at 1000. So if you view the memory at 1000, you can see the same instruction code is putting in the memory. So that's why when you execute the program, you are going to execute at this particular memory address. So it will execute based on this. Okay, it will based on the where you keep the program code. That's why when I ask you to do the program, do not touch the area over here, because this is normally where you put your program, and you do not want to rewrite or something. You're going to replace something new. That's why maybe your program got problems, so you can save somewhere else. Alright, so right now we are going to have this one, IE05. Let's try to look at the manuals. So first thing is you need to look at the manuals. This is the manuals. So it's very long manuals, right? Very long. So what you're going to look at is basically is at the instructions code area, which is nearly at the back. So the page, this one start at ABCD. Alright, so this is the one. Right, this is the section 4 integer instructions. Alright, so we are going to learn about how to use this one. So this is by alphabetical order. It starts from ABCD up to the rest, the other one. Okay, what you want to use right now is the move function. Alright, so we are going to use go direct to the move. It's very long. So the move section is at what, 219 here. 219. Alright, so this is the move sections. Right, before this is LSL. This is another function, another command. So we are going to look at the move instruction over here. So here, for the move, there are how many pages? 1, 2, and 3. So we are going to look at these pages only. 1, 2, and 3. So you need to understand what are the informations that we have over here. Okay, the first one. The operation is source to destination. So you are going to move something to destination, right? Move is just move something to destination. And the assembly syntax is move effective address to another effective address. So for example, here just now in your easy68k, right? Okay, so this is the move. This is effective address, the first one. So I can just use this one. I just want to put the comment here. So this is the first effective address. Then you have the other one, the second one, effective address. The first one is D5, the second one is D7. Effective address is the effective address where is the thing, right? Then you have the size. Size is based on this one. It can be byte, it can be word, it can be long. And then you have these descriptions. Move the data at the source to destinations, location, and set the condition. This one is not going to be assessed by this round. So this is going to be assessed later, but this one you learned before in the past previous lecture. So I'm going to skip this one. This is related to the flags, the X, N, Z, V, C. So this is the one that when you do something, then the flags will be affected. So that will be another chapter. So we are not going to look at this one. So you are going to look at the instruction format here. So this is what we call the template for the move. So the template normally is 16-bit. So you can calculate here from 0 to 15. The size will be 16-bit. Alright, 16-bit. Here, alright, will be 16-bit from the instruction number, bit number 0 to 15. Alright, so let's look at the format first, the template. Here you can see that the first two, the MSB, the most significant bit, okay, 15 and later 14 are always 0, 0. So you need to put all these informations, then you can generate your instruction code. Alright, so next one you are going to read the instruction fields. Here, this is the fields that you need to put. So for the first case of size field, this is this one. Alright, this is this one, size, and this one. So it will based on the size of the operand. Okay, so for this case, you are looking at the byte here. So later you have to use the 01 here over there, 01. Alright. Then you have two parts of destinations and source. So destination is this one and source is this one. So you're going to get the registers and the mode for destination first. For the case of this one, destination first. And then you are going to look at the mode and register for the source here, for the case of here. So where to get these informations? So let's scroll on the other two pages. The first one is this one, and the second one is this one. So both pages are giving you the mode and the register. The mode and the register. This is a table. So the mode and the register, the mode and the register. So these are the tables that you need to refer to put the informations inside here. Alright, so for example right now, if you want to put over here, you have to understand correctly, this is for destinations only. Alright, then this one will be only source. So let's look at the informations what we have on the second page. This is for destination effective address field. Specify the destination location. Only data alterable addressing modes can be used as listed in the following table. So this table is only for destination, which is for this one. And then if you go to the third page, right, so this is a source effective address field. Specify the source operand. All addressing modes can be used as listed as the following tables. So for this part of field, right, source field, you have to refer to this table, not this one. So this is clear, you have to use destination. So this one is you have to use source. Alright, for this one, destination is for this one. So let's try to put the informations over here. Here, just now, right, in your Easy68K, for example, right now this is for your destination. So we have D7 is your destination. So this is the pattern D7. Here you are looking at the pattern on which addressing mode that you are using. In this case, this is DN. So let's put it here. This is move DN to DN, right? So this is data register. This is also data register. So if DN, then you are going to use this one. You need to have this mode and the register here. So what is the definition of register number DN? Okay, mode is very simple. You just directly get this one 000. So you can just put later this one 000. But register is a 3-bit size. What you need to have is the register number. In this case, okay, the register number for destination is 7. So we are going to look at the conversion to binary. So 7 means 1, 1, 1. In binary, you convert back to decimal. So this is 4 plus 2 plus 1 is equivalent to 7. For 5, this one should be 101. Alright, so this will be the value of the binary number for 5. This is 4 plus 1 is 5. This is 4 plus 2 plus 1 is 7. So this will be your register number for this one. So DN later you have to use this one for the register here. Then same goes to source. Source, you have to look at the third page, right here. Again, the DN is this one because this is D5. Then the mode is also 000. Alright, then you have the register number. For the source, this is 5. You are going to use 101. Okay, this is the one. So let's try to insert all this information first. Let's just use this one. Alright, so I'm going to can I use this one? Cannot. Okay, alright, no problem. So let's try to have this one. So the first one, size. Size is dot byte. Dot byte means 01. Okay, now you're going to insert the value here, 0, 0 and 1. Then you have your destination, register and mode. Register and mode. So for destination here, you're going to use this pattern DN. Mode is 00. Register number is this one, 111. So register number is 111, and then the mode is 000, right? This one. And then for the source, okay, the mode is 000, and the register is 101. So you get all the information here already. So now you need to convert it to hexa numbers. So you have to divide by 4 section here. 1, 2, 3, 4. 1, 2, 3, 4. And 1, 2, 3, 4. Okay, now you convert binary to hexa numbers, so you have to use the symbol here. So this is 0010 is equivalent to 1. 11110 is equivalent to E. You can use the what you call that, the your calculator. This is 0000, and later this is 0101. This is 4 plus 1 is equivalent to 5. So the answer for this particular instruction is, okay, the instruction is $, okay, 1E05. So let's look at the results, correct or not just now. Okay, so the instruction code here is 1E05. Okay, so it matched together. So now we are going to look at the other example, right? So I just want to close this one. Close this one. Alright. No. Let's try to use another one, like for example here as D5, or maybe A4 to D2. Right. So right now is the same process you need to understand, or maybe I just use this one, right? Okay, right now it's here. Okay, right now the command now is changed from data register just now to bracket A4. So it means right now you have to use this one again, the same exact thing again. Let's try to use this one. Let's change it to, instead of move.byte, let's change to move.w. Okay, let's look at the first one by one. 00 is always there, right? So then you have the size. Size is a word operation. So word operation is 1 1. 1 here, 1 here. Okay, now look at the destination here. Destination is this one, right? D2. D2 means 010. Okay, this one we are not sure yet. We don't know what's actually it wants, right? Okay, this is not DN. This is bracket AN. Okay, let's look at the first destination here. Destination register. Okay, destination is still using this one, right? Right, this is DN. So the mode will be 000 here. 000. And the register number is D2. D2 is 010. Right? Then you have the source here. Now the source is bracket A4. So based on this table, the bracket A4 is over here. This is AN bracket, right? This is AN bracket, and then you have the mode 010. And then you have the register, still is asking what is the register number for AN. So for this case is 4. 4 is 100. Now you are going to put the here is 100. Later then you change it to hexa number 1234. 1234. 1234. And this will be the answer. This is 2 plus 1 is 3. This is 4. This is 1. This is 4. Hopefully this is the correct one. So let's try to compile this this command. Compile this one. The answer is, yeah, 3414. 3414. 3414. Okay, so this is the correct pattern for the move. Okay, for the case of another one, I want to show you guys another case, right? So for example, this case. right? Instead of this one, so we are going to change it to move.long, right? So this one is maybe D2. This one is directly $2000. For this command, right, this is without hash. Okay, hash symbol, there's no hash symbol, means that this is moving from D2 data register directly to the locations at the address at 2000. This is directly to 2000. So what you need to understand here, right, for this case, so which one to use? So for the case of only 4 digit, right, for example here, $2000, so this is considered absolute short. And if more than 4 digits, right, so for example is 2000, you have another 10 over here, this is considered absolute long. So this is 4 digits, this is 5 digits and extra and above lah. Alright, so this pattern this pattern, when you look at the table, right, you are referring to this one. So this is for the case of absolute short. You have already the mode and the register, and if you have the long one, which is more than 4 digits, you have the mode here 111 and the register is 01. So for the case of data, this is data. Data means that if if the command here is here move.long hash $45. Okay, 45 means you are sending it to 2000. So this is a data. Is it okay? So yeah, it's okay. So this is a data, means that you are referring to data over here for the source. This is destination, right? So you are referring to the source here, and then you are going to get without this one lah. There's no mode and register, so we're not going to use that one at the moment. But we are going to concentrate on these two. Alright, so this is absolute short, this is absolute long. So let's try to get the instruction code for this one just now. Right, D2. This is the command. So the effective address for this one, the source is data register, and the effective address for the next one is the address for the memory. So this is not the right one, so this should be DN, right? This is a pattern for DN, and this one is pattern for xxx.w. Is it correct? Yeah, xxx.w. So let's try to put the information here. Alright, the first two is 00. Size right now is .long. .long means you are using 10. So let's put that the figure over here, 10. And then you have the destination here for the register and mode. Register and mode here based on this one, effective address for destination. So this is absolute short. So you have to refer to destinations absolute short here. You have the mode 111, register is 00. Sorry. So mode is 111 and the register is 000. Then you have the source. Source is data register number 2. So this is, you go to data register. Here is the mode is 000. Register number is number 2. So mode is 000 and data register is 2010. So change it 01234, 01234, 01234, sorry, 01234. Okay, you get the answer already. So this is 2 and this is 1. This is 8 plus 4 is 12. Hold on, 12 for decimal, change to hexa is C, and this is 2. 21C2. Is it correct? Let's try to look at the answer. Yeah, the answer is 21C2. Alright, so refer to this one. This is for the first for the first example of move. So we're going to learn another syntax in another video. Thank you very much.